So I'd like to welcome on the stage for the next session Vikas Tiwari and Kim. The title of the session is Bolstering Security with Zero Trust Framework on AWS.
Hi, thanks everyone for joining this session. My name is Vikas Tiwari. I lead the Solutions Architect team for government business in India, and I've been joined by my colleague Kim.
Hi everyone, good afternoon. I'm Kim, Senior Security Advisor. I'm based in Singapore, but I cover all public sectors across Asia Pacific on security matters.
Can we have the ticker, please? So this is really like a favorite topic of mine, zero trust. I've been working last 5 years with government, and during this time, like every conversation starts with security. So I would like to demystify what the typical security of cloud is. So today we are going to talk about the zero trust architecture framework. Kim will talk detail about it. What I want to start with, just taking a step back and then demystifying the cloud security model first of all. So if we talk about from India perspective, I'm working with, and we all are from public sector, so lots of government customers trying to adopt cloud. There are certain apprehensions, there are certain challenges. So starting with zero trust, I would like to talk about the typical mindset, so a perception. So if we talk to a startup, we talk to an enterprise customers, they are adopting cloud. So they are moving their critical workloads on cloud. But when I talk to government customers, the first thing comes in, they're worried about, we are moving our workload to cloud, which is like a shared infrastructure, so what will happen to my data? Maybe my data is more secured on-prem. So to demystify that, what I wanted to share some basic concepts. Most of the security controls that government typically looks for, and I've been through like lots of RFPs, they are looking for like a perimeter controls. So when I talk about perimeter, think of, I have a house, I feel that if I can put a lock on the door, if I can close all the windows, my house is secure and then I can put everything there and go out safely. But the challenge with the network, this control is we are trusting everyone who is inside the network. So we are taking care of the external threats, but what about the internal threats? There could be many internal threats. I talk about the typical network security if you have a data center or you try to set up a colo setup for your customers. The underlying physical infra, so if you are deploying physical hardware, routers, switches, LAN cables, there's no default security in your network. So by default, network is meant for routing your traffic. There's no security. You superimpose the security. So what you will do, you will create network segments, you'll create VLANs, you are going to create, like you are going to deploy multiple firewalls. So if you look at the architecture, we are talking about an external firewall and an internal firewall. So we create a demilitarized zone, we create a militarized zone, and this is how typically all the network works in most of the customers when we have an on-prem deployment. Now the challenges with this network is, typically this is a static network. Once you have deployed your routers, you've created a VLAN, things rarely change. The firewalls are configured with static IP addresses. If you want to change something, you have to change the firewall configuration. And the blast radius is pretty high. So assume, because we are trusting this internal, whatever is inside the MZ zone, typically all the VMs in a VLAN can talk to each other freely. Administrators wants to access via RDP, via SSH, so all these ports are always open. The IPs are open for other servers, so there's no communication between, or I should say no authentication between two servers. So all the authentication mechanisms are for users. If a user is coming from external world, they should authenticate, authorize, and then come into the network. But within the MZ, there's no authentication. There are few sophisticated customers who have done that, but it's pretty hard to do that. And most of the customers I've seen where we have helped them to move to cloud when there were some malwares, there were some ransomware attacks happened. And the idea was, I'll take you a very simple question. So we all know there was a Log4j vulnerability, right? So can you give me a confirmation that in your environment, if you're running a workload on-prem or colo, have you fixed each and every virtual machine which has got Log4j vulnerability? The answer is, we all know the patching needs to be done, but it's extremely hard to maintain that level of compliance. So the blast radius is high, all the VMs can talk to each other. If a malware exploits, anyone exploits only one window. So if someone is at your house and he gets through your one window, your entire house is vulnerable. So that's where the typical network security architecture works. Whatever controls we are putting at the external layer, the firewalls. And when we talk about AWS, AWS started around 14 years back. So the first thing that we worked on, virtual machines, and the next big innovation that happened was the VPC, the virtual private cloud, the logical software-defined networking that we created. The number one approach was the security capabilities baked into the network, which was not possible in a physical infra. So what I mean with that, you can have dynamic networks. There is a hypervisor layer security controls, hypervisor layer firewalls. We go to AWS. How many AWS users here? Great. So when we go to AWS, we look at first thing, create a VPC. There are security groups available. There is a network ACL, which looks pretty simple. But if you try to compare with the traditional model, your VPC itself is a perimeter firewall. If you have deployed a VM inside your network using private IPs, nobody from outside can access it. So that's your perimeter firewall, which you are setting up like the external firewall in a traditional environment. Next thing is, when we talk about security groups, we are talking about a stateful firewall, which can be configured dynamically. So in this architecture, what we are saying, the load balancers are configured to accept traffic from internet, any IP at port 443. The application servers are configured to accept traffic from load balancer on a particular port, let's say 8080, and the database will only accept traffic on port 3389 for a app server security group. So instead of hard coding IPs, we are saying we will configure the security groups. So that means if you are running 2 servers today, tomorrow because of auto scaling there are 10 servers, automatically all additional 8 servers will be added to security group, and you don't need any manual configuration. So this is a big thing. Because of this micro segmentation, we are reducing the blast radius. So typically in network environment between, like if you are talking about 2 VLANs, for east-west traffic inspection, you need to use some IPS controls. Those controls are embedded by default. The way hypervisor firewall works, if there are 2 VMs on the same physical hardware, they can't talk to each other directly. If you try to send one IP packet, it has to go to the hypervisor. Hypervisor firewall will check, are you allowed to send that traffic? Are you trying to do IP spoofing? That's rejected. If you try to do port scanning, that will not be allowed. So by default, the security posture goes up multiple level. But my point is this sufficient? There are multiple, sophisticated cyber attacks which are happening. So cyber attacks, cyber threats are becoming more sophisticated. The security architecture needs more flexibility. Are we only looking at network perimeter-based security? We have seen during the pandemic, right? So the network, the remote working culture, we have to provide access from remote location, how that impacts your environment. And then the lots of digital transformation projects where you are integrating with SaaS application, there are third-party vendors. So the complexity is growing multiple-fold. And how can we really strengthen your cybersecurity posture using zero trust? That's what I would like to invite Kim to, so he will go, go through this entire security framework.
Thank you, Vikas. So how would you need to rethink your considerations of zero trust in the application of your building, your culture itself. And very importantly, we first need to align on the zero trust definition. This is from AWS, our perspective, whereby zero trust is actually a conceptual security model. And there are actually very specific sets of control mechanisms that your digital assets don't actually need to just depend on network perimeter to achieve its security control, to meet compliance, to meet those cybersecurity threats. Some of these control requirements that we will talk about in quite detail later on include strong authentication mechanisms, micro-segmentation itself, continuous access evaluation. So just now Vikas talked about those areas itself, and we're going to look at these specifically in terms of zero trust outcomes that we're going to be working towards. Your mental model with respect to security needs to have cyber resiliency built into it. And what that means basically is that the 2 dimensions of identity and network They are no longer working in their own silos. They come together. You can blend in and combine identity controls along with network evaluation to really secure that access into the sensitive data that you are providing. Your security architecture must evolve and change to support modern application workloads on serverless, be it the use of containers or the Lambda functions. Your remote workforce itself, and more importantly, providing the public service to your community, to your citizens. You're opening up more and more services that were previously done at the office, at the local agency location. You're opening that up, being accessible on the mobile phone itself. You are doing that today. You got to rethink about your security model that you have. So ask yourself this question. The way you are building today, your security standards, are they able to cater to these requirements itself? Digital transformation projects is happening everywhere. But from what I've seen over the past few days coming to India, you are actually on an accelerated digital transformation itself. COVID was a massive accelerator for you, and having to talk to some of the customers over here, it's amazing on what you're doing. But you need to change the way you think about security from a zero trust approach to support that accelerated transformation journey. Now, our perspectives on AWS perspective on zero trust has 3 guiding principles. We will always work backwards from customer requirements itself. What is the business outcome they're going after, right? And from there, we distill down the various use cases itself in order to achieve that specific outcome. That is important. That's a guiding principle, number 1. Number 2, how the 2 dimensions of identity and network can come together to achieve those various specific security objectives. For example, to reduce lateral movement attacks or risk within your environment, you really need to combine networks that are actually very much aware of identity of who is accessing that service, and that who is not necessarily a human. It can also be a machine. It can also be an IoT device itself. But there is no, on the 3rd principle, there is no one-size-fits-all type of architecture that will suit everything. So what we're sharing with you is about putting these guiding principles in mind, because you will be using them to verify your design builds. Okay? So number 1, the guiding principle itself of focusing on the business outcome. From there, work backwards and build your use cases. Your organization objectives may change depending on the situation, depending on the environment that you are in today, right? There could be a big push towards healthcare, towards more agriculture type of outcomes itself. Those will be organizational objectives that's established by the various ministries and agencies. However, the technical principles, they remain stable. And these technical principles, for example, on machine-to-machine communication and human-to-application, will be trying to reduce lateral movement risk, reduce attack surface itself by making sure that you cover your vulnerabilities carefully, all right? So we're guiding our customers to focus on the business outcomes and work backwards from there while maintaining very specific attributes we'll talk about later pertaining to strong authentication, microsegmentation, continuous access evaluation. The second principle I talked about earlier, now we'll talk a little bit more in detail about how identity and network dimensions, these 2 come together. But before that, let me ask the audience itself, right? Do your current environments that you have on-premise today, are the network controls identity aware? Okay? Think about that. So they don't have to be treated separately. The network-centric controls on AWS side, whereby, because as mentioned just now, you have the VPC controls providing the perimeter protection. And within the VPC, you have various subnets, and you can use security groups that provide you the micro-segmentation control, controlling the east-west and north-south traffic flows. Okay? That provides extremely great granularity for the services that you run within your VPC, be it an EC2 instance itself or a SageMaker notebook instance. You define these things very carefully and restrict who who basically can refer to a system, a device, or a person can access that service. And on the identity aspects itself, on AWS, every call that you have on our APIs, AWS APIs itself, goes through an authentication and authorization aspect itself. And that is known as our signature version 4 signing process, whereby your API calls to an S3 bucket, to an EC2 instance, actually uses your access key to verify your identity, and then are you authorized to actually access the S3 bucket itself, to perform change of policy, to download an object, to delete object itself. Every single request is verified before you are permitted the action. Now, let's combine both together itself. So in the instance over here, whereby you have a security group that protects your EC2 instance, it limits its ability and controls who can access it from a network perspective. You've now combined the actual VPC endpoint over here that's deployed to your VPC to control the private access to your S3 bucket. Your S3 bucket will have definitions that specifies that I'm only allowing this specific VPC to communicate and retrieve objects from my side. Okay? And you can be very restrictive and very, very granular in the aspects on specifying selected instance profiles to actually access that, on top of your VPC definition. The third guiding principle that I talked about before is being flexible in your implementation of Zero Trust itself. There is no one-size-fits-all architecture, but you would need to build design architecture patterns to support this principle. Now, having talked about the principles which are basically setting you up, understanding how to build to achieve your business outcomes for your organization, these specific Zero Trust attributes are the associated type of controls that we've mentioned before, right, to fulfill those principles. Strong authentication and authorization is part and parcel, okay? I want to emphasize to everybody that multi-factor authentication for humans should be applied to all users and should not just be limited to administrators itself or to a select few. Where possible, we strongly recommend the use of multi-factor authentication for all users. And for the machine-to-machine communication, rely on cryptographic-based authentication, right? The API calls within AWS itself relies on mutual client authentication mechanisms too, okay? These are available to you today. It's by default available. Granting least privilege access and enforcing strict access controls is a regime that you have to build into your security model itself. Providing the right size set of permissions for your EC2 instances, for your containers, are fundamentally necessary to reduce the blast radius that Vikas has shared earlier. All right? Giving an EC2 instance or container excessive privileges, for example, giving it all action to actually exercise controls on an S3 bucket would be excessive if your intent is only to download objects. Because what you're actually doing is that you're providing permissions to an S3 to change the bucket policy to terminate the bucket itself, which can have catastrophic outcomes. So remember about the enforcing strict access controls itself. They all come together for the human access itself to the application service and also for the machine-to-machine. Access control should not just be limited to the human interactions, but for example, if you're creating a smart nation grid itself, IoT devices also need to enforce strict access controls, okay? Second attribute on microsegmentation. Microsegmentation over here has two areas I want to cover very carefully with the audience today. First one would be separating your workloads into different accounts, into different AWS accounts to be specific. A workload that is responsible for handling payments should be in its own AWS account. It should not be mixed with other types of accounts, for example, that's related to security or for central logging. It is specific to its purpose. okay? And we also strongly encourage to use different accounts for different staging environments. For example, development should have its own account for that financial payment service talked about earlier, and a different account for your production. This provides you with very granular control and limiting the blast radius should there be an unfortunate security event. And breaking down these objects from an account level, you can go into a micro implementation of the parameter itself, right? So security groups are a very effective way that Vikas has shared earlier on how you can implement micro network segmentation controls in combination with network access, in combination with identity controls. Continuously evaluate the permissions, the requests being made, right? This attribute is crucial to make sure that every single request meets, is actually valid itself, and it's done by the correct entity, and it's got coming from the correct location. So every single request that you run for AWS to retrieve a S3 object, to retrieve a data from the DynamoDB, these request API calls are authenticated using and verified using your access key that I mentioned earlier. And more importantly, when the resource or the service is actually requesting for the short-term credential, we do not use long-term credentials itself. And for all users itself in the audience today, please move towards short-term credentials itself. Minimize the usage of long-term credentials like static passwords or IAM access keys itself. Minimize those. Security monitoring should not be done at one point in time. It's a continuous evaluation. Put in place mechanisms for you to detect creation of assets, modification of IAM policies continuously, and be proactive in being able to respond to these alert events that come up in an automated way to make your life easier, to be more productive, and also to reduce the time to respond, okay? And on the area of trust, specifically the word trust itself, right? It's very important that you put in place mechanisms in your architecture to reduce the potential abuse of trust. And this also looks at it from an inward perspective in terms of your organization implementation. Inspect and log all your traffic itself. If you have services that need to connect to the internet to pull information, to retrieve and download application libraries from published on GitHub or other repositories, you should inspect where and control where it's retrieving the information from, okay? Encrypt everything, okay? Encrypt your information that's stored in the S3 buckets, information that's stored in your DynamoDB. We have provided robust encryption capabilities for our customers itself, not just at rest, but also in transit. So encrypt everything. Leave it to no chance. And with that, automate your development and your creation of your environment itself by using infrastructure as code. That is fundamentally important. Why? Because you can put in place mechanisms to check and scan linting of your infrastructure as code to make sure that there are no excessive privileges being provided to resources being created. For example, you want to be catching anybody creating EC2 instances or containers with wildcard actions given to it. And code linting is an effective way. Especially for containers, you want to check your Docker files very carefully, making sure there are user directives being specified there so you don't run your containers with root privileges. So reduce the potential for abuse of trust by actually automating infrastructure setups, automating the capability to check code. As I shared earlier, AWS, we have, in order to spin up the resources, to make changes to the compute resources, millions and millions of requests are being sent to the AWS API. We get we support millions of transactions per second to these APIs. Now, we authenticate every single and authorize every single one of these requests, all right? We make sure that we verify your identity using your access key before we actually authorize and verify your authorization to access the resource. And this is done millions per second. And we use this process of signature versioning 4, whereby we sign and validate specific requests. And this is important because not just we verify your identity, but we also reduce the risk of a replay attack itself happening in the environment. So, are you able to achieve this in your on-premise environment today? And in terms of the different AWS services that interact with each other, in this specific instance, we have an EC2 instance in a private subnet that is trying to retrieve information and read and write information to a DynamoDB. For this interaction to take place, the EC2 instance actually has a specified instance role. It will obtain from IAM service its temporary credential and assumes that specific role. Within that IAM policy, the instance profile role, it specifies its allowed permission to actually read and write information to the DynamoDB. And before it can, when it fires off that request, there's a signature signing process for that specific API read call to DynamoDB, right? That signing process is crucial because on DynamoDB side, it will take that signature and then do the certificate verification. Is this permitted? Is this authorized? If it is, the transaction is allowed to proceed itself. And moving on to the areas of IoT itself, we have made significant advancements itself on the IoT space. Now, with the implementation of AWS IoT Core, we have put in place mutual client authentication. There is TLS there by default. It's all available. And with respect to free real-time OS, whereby you can actually put in place now today TLS encryption by default for your small microprocessors itself. This is whereby we are lifting up the capabilities, right, for encryption itself network in transit protection for many, many different IoT devices. And in the area of handling highly sensitive information, processing of highly sensitive information with your EC2 instance, we have Nitro Enclave. Nitro Enclave is an isolated compute environment that is running on EC2, and it's got a parent instance itself that it communicates with only via a secure local channel. You would be able to process very sensitive workload information by actually allowing only code that actually has been signed. There's an attestation process itself, right? The administrators of the parent EC2 has no access to the information within the enclave. So it's done very, very securely. You have isolation of the vCPUs. You have isolation of the memory itself. And this is the next level of much granular microsegmentation that you can think about itself, right? This is reserved for very sensitive data processing itself. So now I'll hand over to Vikas to cover on CoWIN.
Before moving to CoWIN, I'll just take one more example regarding the Nitro enclaves. This is very interesting. Working with government departments, we get interesting requests, right? So there are lots of departments which are handling tenders and like lots of public money. And what government wants, they don't want even the internal user to get access to the tender quotes before the bid opening. So it's a very sensitive thing. If it's a very large tender, this is lots of public money involved, right? So there is always an insider threat. So this is a kind of technology that you can leverage. There's an area where even if once you have configured, even if the root administrator of the VM tries to log in, he cannot access the details inside it. So if you are using the key, which is stored in the Nitro enclave, so if you're using a bid application, so once someone submits a bid, the bid has to be opened, it has to be decrypted. If it can only be done by your Nitro enclave, and then you put the logic that with this time frame, before this time it can't be done, and whenever you have to do it, there should be a proper way of authentication by the business users. So now that control you can give it to business users with way of application logic securely built into the Nitro enclave. So multiple ways, I'll take one more example. So we have a requirement like if there's a critical workload, we want to ensure even if there's some internal person who tries to dump entire data, he should not be able to capture much information. So assume you have PII data of citizens You have got username, you have got some details and other parameters, address, everything. You split it in multiple parts. Typically in RDBMS, we have got foreign keys, how we do it. So you split the data formats across like different segments so that each data fragment has no value. If you have a list of users or list of mobile numbers or list of like some other details, addresses, these are just a list. You don't know which user is connected to which address. So the token, you can define a token which can do this correlation, which user is connected to which address, and that token decryption logic, if you put it in Nitro Enclave, that means if it's there, it's a very secured way to ensure that only application knows which data, which user, which address can be done at real time when application is accessing. If someone tries to dump data, he will have no sense of what the value of this data is. So moving, like this is a great way of confidential computing. We can use this, leverage this to take data security at the next level. Talking about CoWIN, we were really fortunate 2 years back. So we started in 2020. We got the opportunity to design the Arogya Setu application so that we can in 10 days roll out an application on cloud. Using a cloud native architecture, we were able to design a secure application. There were lots of attempts. Global hackers tried to go after the application. All they could do is decompile the Arogya Setu mobile app, tell what APIs are there. If you pass different parameters, different coordinates, it will tell you different information. But eventually they couldn't go past the backend architecture. So we leveraged lots of learnings from that, and when CoWIN had to be designed, we designed again a similar scalable model where it can just scale to whatever. And frankly, I mean, we come to know in less than 24 hours notice that we are going to celebrate PM's birthday and we have to do 2.5 crore vaccinations in a day. So frankly, what all we did was we ensured all our product teams are there on standby so that anything goes wrong, we check the limits. Earlier, the API gateway in the front, maybe I'll show you the architecture as well. So the API gateway was typically handling like around 20 to 30,000 API hits per second. That's the traffic normally peak we have seen when we were doing like 10 million vaccinations a day. On 17th of September, like we saw unprecedented scale. Our team was on standby. We were increasing the soft limits in the backend. So in short, we increased up to 50,000. That's what we projected, but it went as high as more than 70,000 hits per second. So that's a huge scale. That day we got like at the cloud front, we got more than 4 billion hits. So this is the architecture of CoWIN, how we implement it, as Kim was talking about, not just network security controls, but also the identity controls. The traffic end users, you might have used CoWIN. It's first of all hitting the cloud front. So again, lots of interesting use cases. The caching at CDN we did for 30 seconds. There's a misconception. People think that CDN can be used only for caching your static content. Here the dynamic content, when you go to cowin.gov.in, you see a list of platforms. You search for a pin code or a city. You see a list of hospitals. We were caching that information for 30 seconds only. That's caching on CloudFront. So we were saving our application, again, a level of protection from the burst of traffic that we were getting from all country. 96% of the traffic was served from cache at CDN. So think of it, whatever API hits we are talking about is only like 4% of the entire traffic. So then CloudFront locations, we kind of ensured that with the custom headers, that API gateway only accepts the request from CloudFront. Load balancer is integrated to API gateway, and we have got WAF deployed at load balancer and CloudFront. We were doing DDoS Shield advanced protection there. And then the security groups, you can see that for load balancer, for Kubernetes cluster, there is a relational database for master data, and then the main transactional data was DynamoDB. So again, as we said, it's very important how you design your architecture so it can scale and it can be securely verified. So the access was only restricted to Kubernetes cluster by the VPC endpoint. So, and then we put the resource controls, the policies, so that only the production control can, or production cluster can access the production tables in the database. So this is how we kind of handled at the API gateway level. We enabled caching, we enabled throttling, hardening of the APIs. We did an APM integration, the X-ray, so that we are tracking in real time. So it's like, I mean, APM is like doing a sampling, right? So we were taking 10% of the samples. We were capturing how many users are getting how many errors. So for entire 1 month, we started with huge number of errors starting January 21. And eventually, in like 3 months, we were able to bring down all the API response time. We were tracking P99 to less than 1 second. So that was a huge achievement, and you might have noticed that once it was stable, it just scaled and worked. So extensive logging, real-time monitoring of entire system, 100% encryption for data at rest. We were using the complete CI/CD pipeline, and whenever we were trying to push the new code build, we were scanning the images, ensuring there's no vulnerability, and only that it was pushed. Guard duty played a big role. We have done geofencing. We had put lots of bot controls. You might have seen lots of people wrote bots for CoWIN so that they can get the availability. So we understood the problem. We wanted to control. We controlled the bots at one end. We also provided some other APIs so that instead of you pulling and polling this system, let's give us a push notification so that some organizations like Genuine, who had this integration like Paytm and others, they integrated with the system and they were getting the push notifications whenever the new vaccinations were available in the country. So again, if you look at, there's no human interaction, there's no unauthenticated communication happening anywhere in the system. And it's not like if you use AWS, then only it's possible. Even if you are using your own microservices, you have designed, let's say, a Kubernetes-based applications, and I'll take another example. So lots of common services are there in government. If you're providing an SMS service, you typically rely on a whitelisting of IP address, right? So you just whitelist it, there's no authentication. How can you do that? So that's also one capability we can do it. And if I look at how you can start your zero trust journey, we need to really learn about 3 things. One is the networking services of cloud. So a typical standard network is fine, but then when you have multiple VPCs, multiple sub-accounts, as Kim mentioned, it becomes complex. How can we simplify it? We need to learn about the identity services and the zero trust capabilities. I talk about the confidential computing. So in terms of networking foundation, reducing the network complexity and improving security and then monitoring and management, there are 3 fundamental services I really want you to learn about. One is the capabilities of VPC. So one is you can have multiple VPCs, and within VPC also you can have lots of sophisticated routing capability, what we call the advanced VPC routing. With that, within subnets also, if you want to say that there are 2 subnets, but you want to put like a network firewall or an IPS for east-west traffic inspection. So you can define that routing now within VPC. So lots of innovations happening in that space. If you have multiple VPCs, instead of doing VPC peering and making it really complex, you can use a transit gateway. And then private link is I really like this service. Suppose you have created a service, how will you share that to different organization or different department? Typically you will host it given a public IP, it will travel over the network, and you will do IP whitelisting at the max. Here private link, what it does, it's like a gateway, one-way routing gateway. You don't need to do routing between 2 VPCs. So basically, if I say I'll create a private link endpoint, I'll drop it in your thing. So suppose I'm the provider, I have a SaaS-based service I want to create, and you want to access it. So I will create a VPC endpoint. That VPC endpoint will be in your VPC. So now you can use that private IP of that private link and can access my service. In the backend, that IP will redirect to my network load balancer or application load balancer. So there's no way to do any kind of public internet-based routing. It will be completely private network-based routing. And apart from that, you don't have access to any other components in the network. So great capabilities from networking you can learn. Similarly, from identity perspective, one is the AWS organization. So the innovation one I would definitely like to manage is, like mentioned here is, you might have heard of landing zones and control tower. Are you aware of control tower? It provides lots of automations. You can build control tower, and then you can create OUs, organization units, can create, it's an account vending machine. Now we are working with lots of government departments. Lots of government departments says, we want to put some guardrails. We want to say that, I want to have a shared network infra. So I'll set up one account where I will have my, let's say, a network firewall. I want all my traffic to go through it. If you create a new child account, AWS do it very easy that it will create a default VPC, which will have a like an internet gateway. So customers don't want it. They want an enforced system. If it's a production system with critical data, can we kind of disable all the controls? Like if I'm operating, I'm a government customer, I can't operate out of India. Why are you enabling everything? Can you put such guardrails that all of the regions are disabled by default? I can have a shared network created. So all those things are created as part of a solution called Landing Zone Accelerator. So experience that. It's on top of the organization. Similarly, AWS SSO is now called AWS IAM Identity Center, which will help you to rely on the short-term credentials. And then you can do tagging resource groups so that you can give access to users based on tagging only. So instead of giving IAM roles, create one role which is based on tagging and policy. So if you want a new person to get access to my project, just give that person's name there in the tag. So lots of advanced controls there, learn about it. As Kim mentioned about the SIG-v4, the VPC endpoints, please enable add instead of accessing from VPC within your like environment over the internet, use these endpoints. And this is a great resource. If you go to aws.amazon.com security/zero trust, there's an AWS perspective, zero trust architecture. I would really recommend that you go through it. It will have lots of perspective how you can leverage the confidential computing. Yep, so just to summarize, learn about networking services, identity services, zero trust, secure your leadership sponsorship, and then use the guiding principles and attributes as we discussed. Yep.
Okay, so we've gone through a lot about the guiding principles and attributes. We seek your commitment itself to rethink about security, what you thought about of your on-premise network-based type of controls in a new world which you are in right now to do those accelerated digital transformation. Use the zero trust principles that we have shared and these attributes, create the design patterns that meet those specific use case demands itself, right? So we are here to help you itself to look at the specific objectives and outcomes you're going after, right? So get yourself trained up, get your certification done, and the AWS team is here to actually help you, right? We're committed and we're customer obsessed, making sure that you are successful and secure in delivering your public services to your community. We're now open to taking questions itself. Please.
Yep. I have a question. So,
Give the mic.
hello? Yeah, I am Atul Duff. Basically, I had one question. So you mentioned about the principles behind zero trust, one of them being strong authentication factor, right? So, I mean, these days now, the industry is talking about going passwordless. So how do you take multi-factor authentication as, one of the strong principles behind authentication factor? Will it, if I go passwordless, do you think will it violate the zero trust principles, or what is your take on it basically?
So you want to take that?
Okay, so passwords will continue to remain. That's the reality itself. We are on the very beginning towards passwordless authentication. Now remember, it is still a very form of cryptographic based type of authentication mechanism. So it's still very much valid in terms of modern day authentication mechanism. So passwordless is still in line with the zero trust concepts itself.
So it's passwordless, but it never says it's not authentication or authorization.
It is definitely authenticated, yeah. Definitely.
So this FIDO organization which has created this concept of passwordless so that you can leverage the existing authentication mechanism like your fingerprint on your mobile if it's there. You are already authenticating with password, so you can have a security posture on your, that's something as a policy you can check whether there's a strong password on your mobile device. The fingerprint authentication is there. So if that's there, so I'll say that it's a different way of authentication, but authentication, strong authentication and authorization is the fundamental of any communication. For human, it's there, but if you talk about the machine to machine, it will always be passwordless. So maybe
certificate-based
certificates,
itself.
temporary credentials. I'll tell one more example. So databases, typically we have a credential, right? So what customers are doing now, they are using some capabilities like we have got secrets manager. it can automatically rotate. So you can rotate the credential on a daily basis so that nobody knows. If you want to access the credential, the application will access the secrets manager. It's based on encrypted key. It has got access control and it's getting logged. Who is accessing the secrets manager? Any administrator wants, every time he has to go to that secrets manager, get the key to access the database directly. So there are multiple ways how things are evolving.
I had one other question as well. I think this CoWIN example was a very beautiful example, in a very short duration of time, how, the technology was put in place to, handle data for so many, 1.5, 1.4 billion people, right? And so I just wanted to understand, like, with respect to latency and all, because, we understand that AWS has its data center primarily based out of Mumbai currently. Of course, there's something coming up in Hyderabad as well.
Yeah.
But with respect to, the data center available only in Mumbai, so do you think that was a challenge to, manage the latency between geographies across India, like, data coming in from the people from all over India, basically?
So we were tracking the real-time monitoring of the application, and this is again how we scaled the application. It was not running from one data center, it was running from 3 different data centers. All the components, the Kubernetes cluster, of course the other components by default, DynamoDB, the load balancer, the API gateway, they are anyways multi-AZ. So all the components were running from 3 data centers. When there was a spike, so we were able to in the backend handle or scale the resources across all 3 data centers. As a matter of fact, the DynamoDB scaled to 600 partitions in the backend at the peak. So think of it, we are running a database cluster of 600 nodes, which is not practical if you would have to do it managing your own database service.
Right. And also, like you mentioned about, very good security measures put in place. Like, you mentioned about AWS Duty Guard, also for the application scanning, also inspector and all, right? So, did you face real-time challenges with respect to, hackers trying to steal the data? And I mean, could you share examples? If it's not confidential, can you share examples? What kind of attacks?
I'm not sure we have enough time, but yes, there were lots of incidents. I mentioned about Arogya Setu when the global hacker openly said we are going to break in. And we were there along with Certain and NIC and lots of other teams who all were collaborating together and monitoring the system. So important is the visibility. We saw one attack on the admin login module once. So immediately we saw a spike, and then we tried to mitigate that, put some WAF controls. That authentication login failures more than 3 from an IP was disabled. So those kind of controls were added.
Wonderful. Thank you very much.
So just one small question.
All right. So maybe we are
We can
outside.
take the question offline itself.
Sure.
We'll still
I
be
think
here.
it's time for next question. We are here outside. Yeah, we can discuss. Thank you so much, guys.
Thank you, everybody.
Thank you so much.